Okay, so and also the reason why I want you to understand abstract classes is because in chapters 15, 16, and so on, most of those examples in those topics already means that you understand abstract classes. Okay, so when they mention in the chapter book, in the chapter, it assumes that you already know abstract classes. Because if you follow the book, abstract classes covered in chapter 13, so by then you should already know. But we didn't cover that in the Java 1, so I want to just spend today just a one simple unit just to get you up to speed with the abstract classes and interfaces. So in here, you just have one tiny assignment, but I want to go over some notes and then we'll do some examples together if you want to follow along. So you get the hang of it. So I put some videos in here as well to linda.com just to these are really brief videos. It's about like 5 minutes, 6 minutes long, so it probably won't cover everything in details, but at least it will help you see how abstract classes and not just classes but methods as well can be implemented or created in Java, and then of course the interfaces as well. But I want to look at my notes in here, and if you remember inheritance, I already have that open. So we have the inheritance in Unit 10 in the summer class. If you were in my class before, we covered that as well, right? So inheritance means you have some kind of relationships between a superclass and a subclass. So a parent class and a child class, right? And so just like if you think about a family tree, right? You have the parents and then the children and then their children, and so you have the tree structure there. So the inheritance is usually referred to as the is-a relationship, okay? Because apple is a fruit, right? A fruit, and then fruit is a some type of a plant or something like that, right? So you have that is a relationship. Whereas the other one is has a relationship is usually referred to a composition, right? We talked about composition before, and if you were in my class, we talked about the the sandwich classes and the fillings and so on, right? So it's composed of other classes inside another class is called a composition. But I want to just briefly review the inheritance. So I want to show you this diagram here again. So we have let's say a parent class and then the child class, and the arrow is pointing to the parent class, right? So in this UML, UML is always drawn this way. So if you see the arrow pointing to another class, that means the class that is being pointed to is the parent. So in this case, this is the parent class, right? So the child class is always the class that is pointing to the other class, okay? So or the subclass in this case. So a child class can only inherit one parent class, and those are the rules, right? You cannot have a child class, pointing to 2 or 3 parent classes, okay? So for example, like in apple apple is a fruit, but apple cannot be a vegetable, or cannot be something else, right? So on one type. But a parent class can be inherited from many subclasses. Okay, so I can have a child 1 class and child 2 class, and all pointing to the same parent class, right? So so that's fine. So another diagram here, like car is a vehicle, right? It's really a much broader class, which is the parent class. A car is a vehicle. We can have a boat is also a vehicle. Even a bicycle is a vehicle, right? You have subclasses that are related in that nature. And then you also have, again, I showed you last time, so again, the multiple inheritance. 2 classes, subclasses can inherit the same parent class. We have, again, here, multiple subclasses are inherited from the same parent class, okay? And then this example here is, and we're talking about concrete classes. So what are concrete classes? Do you remember we talked about that in the summer? I know, like a couple weeks back, but or maybe your Java 1 class or other object-oriented programming class like PHP and so on. What is a concrete class? What does it mean when we say a concrete class? Any anybody want to guess?
built into the language?
No. Well, I mean, sorry. Well, yes and no. So yes and no, right? So a concrete class is like it is. Right? It's a complete class. That's what it is, right? It's a concrete, and we'll compare that to an abstract class. So a concrete class is a class that has everything in it. It's a class that can instantiate or can create objects out of it. Okay, that's a concrete class. So, for example, if you have a class called student, if you can instantiate an object out of that student class, then that is a concrete class. It's a complete, full, solid class, or we just call it a general class. Okay, and then when we go to the abstract part, you understand why, or what's the difference between a concrete class and abstract class and interface class.
You're saying a concrete class is a non-abstract class?
Yes, a non-abstract, a non-interface class. Okay, so it's the opposite of an abstract class. Okay. So now with that said, we have something called the polymorphism, right? We talked about that. We studied polymorphism, and that's when we overload and override methods. Okay, if you remember those. We have something like, for example, in the parent class, we have the method 1, 2, and 3. All these methods are in the parent class, but they can also be overloaded, right, or overridden by the child class in here. So there is a subtle distinction between overriding a method and overloading a method. Do you remember what those are? What does it mean when we overload a method or we override a method?
Overloading a method?
Or sometimes method overload.
Different implementation or extra arguments or
the second part. Okay, not extra, but different arguments. Okay, so that's overloading.
Yeah,
okay?
Different data types for the arguments.
Yeah, you can have different implementation as well inside the body of your function or your method, but for a method overload or overloaded method, you have to have a different either data type or number of arguments, or we call those parameters in your function head, right? So that's overloading a method, and the name of the function will be the same. The return type is the same. Or it could be different. It doesn't matter, right? So we have overload is when a method has the same but different signature, right? I should say, same name, different signature. So again, the signature here means you have different number or different type of parameters in your function head. And then override is when you have the same method in your subclass, okay? Has the same name and same signature as the parent. Okay, it has to match exactly as that, and then you will have a different implementation in the body of the function. Okay, so like here, for example, if you have a parent method called method 1, as let's just say there's no argument, and then in the child class you also have the same method called method 1, and then maybe inside method 1 in the parent class, it would just say print a statement, but in the child class, it would do something else besides just printing a statement. Okay, so you have the same name, same parameters, exactly same, but then the function body is different. So that's overriding. Okay, you're overriding the parent's method. Okay, so you can have both of these combinations in the same class, right? So you can have both of those. Okay, so with that said, I'm going to go over to the other note. So this is from the Unit 10, that's from my summer class. So if you want to review that, that's for you to review. So I'm going to go over to the Chapter 13 now in the book. So abstract classes and interfaces. Okay, so abstract class has these features here, all these like bullet points here, and I'm going to go over through all of them so you understand what they mean. Sometimes reading it, it's much harder to understand than seeing in code. What does it mean when we say constructors are invoked by subclasses, not by abstract class, right? So I'm going to walk through these bullet points to show you, to demonstrate to you how they work, and so you can understand the difference between abstract class and a concrete class. Okay, so again, I put a note here in order to write code correspond to user interactions. You will do a lot of these in chapters 15 and 16. Okay, so next week we'll do Javafx. Okay, FX will get you acquainted into the GUI interface, and the weeks after that, actually probably 3 weeks after that, we'll dive into chapters 15 and 16. You do a lot of event and user actions, more of like mouse click and keyboard entry and so on. So that deals a lot with the abstract classes and interfaces. So it's important that we understand what these are. Okay, so an abstract class, and if you look at the word for the word abstract, that's what it means. Okay, it's more abstract than a very specific class. So a concrete class is much more specific than a abstract class. Abstract class is will be for a class that has some common features that can be shared among the subclasses. Like, for example, the vehicle class, right? The vehicle can be abstract because, in a vehicle you can have, so for example, you can have like these start engine, right? Turn off the engine. How do you open the door? And all those, how you step on the brake. All these are common features for cars, right? Or even boats and things like that. So they have common features, and because they're common, you put that into an abstract class. And so those individual functions can be implemented locally inside those concrete classes. Okay, so the rules are that classes, abstract classes, they're like regular classes. They can have both data and methods. Okay, that means they can have both instance variables, right, and methods. But you cannot create instances out of these abstract class. That means you cannot use the word new, right? So you can say, student S1 is equal to new student. You can't say that do that in the abstract class. Constructors are invoked by subclasses only, right? So because you cannot create with the new, you cannot invoke the constructors directly. You have to do that indirectly from the subclass. I'll show you what that means. And the class name or the class and also all the methods, if they are abstract, they have to be denoted with the keyword abstract as the modifier. Okay. And then the functions and again cannot contain a non-abstract in a non-abstract class. So I mean they kind of like redundant in a sense. So for example, you cannot have an abstract method inside a concrete class. Okay, you cannot. Okay, only inside an abstract class you can have it. So that's why it says class contains abstract methods must be an abstract class. Okay, so these, I know it's all kind of like convoluted, but it's much clearer when you see the code. And so a subclass, the subclass of an abstract superclass, like let's say if the parent class is an abstract class, then the child class must implement, okay, I put that snap, but must implement all the, if there are any, abstract methods in the parent class. Okay, that's what this means. But it's worded differently, but it means the same thing. If a subclass of a parent class, abstract superclass, does not implement all the inherited abstract methods of that superclass, then that superclass cannot be defined as abstract. So I mean same thing, we just worded differently. So a subclass can be abstract even if its superclass is concrete. So your parent class can be a concrete class, and then the child class can be an abstract class. That's what it means. You can go either direction. Okay? So let's go over each of these bullet points. So I'm going to create a few examples to show you what these bullet points mean. So I'm going to use, just briefly to show what that looks like. So you have an abstract class called fruit, right? And you use the keyword abstract in front of it, in front of the class here. Previously, we never see this before. We just say public class, the name of the class, right? Or private something something. And same thing here for a method, you would say public or private, the void, the data type, and then the name of the function. We didn't use the word abstract before. So this is a new keyword that you can add to the abstract method. So an abstract method, if you implement, if you define or declare a abstract method like this inside a class, then you are not allowed to, you cannot implement the body like this. Okay, you cannot do that. You have to just basically provide the the blueprint of that method. So the body of that of this method cannot be created inside this class. It has to be created under the child class. Okay. Why? Well, maybe because this method here it doesn't apply to whatever this abstract class is. Like, for example, if I put start engine as a function inside the vehicle class, how do I know that, you know, this vehicle, this car, do I need a key? Or if it's a boat, do I need a key? If it's a plane, do I need a key? Right? So you don't know what that object is. So therefore, you just say all the vehicles must start the engine. But how? Okay, I'll leave that to the subclasses. They do their own part. Okay. And again, I'll do some examples to show you. So you can have, so in the abstract class, you define as a public abstract the class and then the class name. It's kind of like the regular class. It looks just like a regular class. Inside here, you can have, you know, variables just like you had in the regular class or on the concrete class. Double type, you can have constants, you can have other fields here. And then your methods can also be just your regular methods here. So this is a regular method, all right? It's a void. It just says set calories, and then you set the calories, just like you did before in the regular class. This is also same thing, right? So the only differences are here. You have the word abstract for the class here and abstract for this method here. Okay, so this makes this whole class here an abstract class. Okay. So what that means is that I cannot create an object out of the fruit directly. So in other words, I cannot say somewhere down in a different method, fruit, you know, f is equal to new fruit. Okay, you cannot do that because it's an abstract class, and that is the rule of not just Java, but pretty much for every object-oriented programming language. Okay, you can have you can create a constructor in here if you want, which is fine. But you can't instantiate it directly. You have to instantiate from a subclass. So now I have another class. So this class here, the Apple class, as you can see, it's a regular or a concrete class because it doesn't have the word abstract there, right? So this Apple class extends, again, this is inheritance, right? Inherits, same thing, the fruit class. Okay, so the fruit is the parent class in this case. It's an abstract class. It inherits the fruit class, and so therefore it has access to all of these, the variable calories and all three methods here. Three methods. Two of these methods are implemented already, right? This one is not. So this one, because it's not and it's an abstract method, any subclass that extends the fruit class, okay, any subclass. Here in this case is apple. If I put banana, or cherry, and so on, okay, all of those subclasses, they must implement this method. Okay, so meaning they have to do something like this, right? Provide the functionality of that method, even if it's blank. So that's what you see here. This class apple must implement the show fruit, exactly as it is here. The function head has to match exactly the same. Okay, so basically you're overriding that method without the keyword abstract. Okay, you took the abstract keyword out, and then this method here is implemented inside the child class of here Apple, and then so you do some code in here if you want. If you don't, just you can leave it blank. That's fine, right? And because a method can be just a blank method, and so when you do that, then this application will be happy. There's no errors, and it's fine. So this is a subclass of the fruit, and then down here we have another class, a third class called seed. So seed extends the apple class, right? So seed is the child of the apple, and apple is the child of fruit. So we have three different classes. And so now this is where the main application starts, right? You have the public main method here. Okay, so you can do all these just like now you can treat this like a regular application we used to do. So apple is apple, new apple. So I cannot say something like fruit, right? I cannot say fruit f is equal to new fruit. Okay, this will not work. Okay. Because fruit is an abstract class. Okay, so that's the rule. Okay, so I'm going to do this example to show you the concrete class. And I wanted to do all three, but I'll just probably do two of these triangle and the rectangular class. We'll do those as a concrete class, and we'll calculate the area, and we'll see maybe even like the perimeter or of those two shapes. Okay, so and then I'll also create a main class to create those two objects there. So back in here, let's create a new project. It's going to be just a regular Java class. Okay, this is not going to be Javafx or any of the other GUI interface. We just do the regular Java, the console application like we did in Java 1. Okay, so we'll create a new Java project, and if you remember, do this. Give it a name, right? So I'll just call this or just chapter 13. So the project name is just chapter 13. You can call it whatever you want. I'll just call it that. And I'll accept the default if it's not. Just make sure you select the latest version, which is 1.8. But it should be selected by default already. If it's not, select that one. Just click Finish to create that new project. Okay. So now we're going to create a concrete class, actually three classes, but the first one is going to be the triangle. So create class, just click this icon here, much quicker, and the name will be just triangle. And remember that in classes, and the name of your classes typically should always be singular, okay? Because each object we're talking about, when you create an object out of it, it's a single object out of it, so it's usually singular, okay? Whereas if you remember in database, your tables are usually plural. Okay, it's opposite. So the triangle class is going to be a public. I will do the constructor. If you click that, I mean it's going to create the constructor automatically for us. So save us some time. And I don't want any comments. So and then just click Finish. We could add package, but for now we just say without package is fine. Okay, so I have my triangle constructor here. It's blank. We'll do another one. So let's add another class. This will be the rectangle class, and it will be just the same setting as the other one. So here's my rectangle class. And then we'll do another one for the main project. Okay, so create a third class, and we just call this main program is fine. So the main program. And so this one is going to have the static void main method. We don't need to create constructors, so we can uncheck the constructors from the superclass, and just click finish. Alright, so this is the main application. It starts here. I'm just going to remove these comments out. Okay, so in here we'll be instantiating a triangle object and then a rectangle object, and then we'll print out the area and parameters and so on. Okay, so let's go back to the triangle class and add some stuff in here. So I'm gonna turn this off. So this is like, if you remember from Java 1, we leave that as is, right? Because once you create a custom constructor, you want to leave one that's blank, so that when you instantiate the object of triangle without any parameters, it can still be created. Otherwise, you will always have to create something, use some type of variable name. Well, if you think of a triangle, what do we have? If you want to find out the area of a triangle or the parameter, if you remember what's the parameter of a triangle, of a shape, is pretty much the distance around the triangle, right? So we need three variables for the side 1, side 2, side 3, right? So I'm going to create just a private, we'll just call it B1, B2, and B3 for the base 1, base 2, base 3. And also I need the height, so just call it H. Okay, make it kind of simple now. I have to say we'll call this double, and they're all double. Okay. And then we're going to create the setters and getters for those, and we'll do the shortcut. So if you click it down here at the bottom, do a right click, and then go to source and select the generate getters and setters. Okay. And this should list all of them here, and we're going to do for all of them in this example, so you can check all of them. And you can pick and choose, but you can do all of them. And they're all going to be public. Okay? And if you have this comment on, you can check it so there's no comments. If you do, then it's going to put a comment about each of those methods. And in this example, we're not going to do that. So just click OK. And then we have all these set up for us. So we don't have to do that anymore. We're done with that. Now, so if you go way to the top here again, it's going to put those on the bottom for now. And so these are, setters and getters, but really these are like properties. Okay, the properties of your object, of the triangle object. So if you want to return the base 1, then just say get B1. Base 2 would get B2, and so on, right? But I want to have another constructor for the triangle, so that when you create a triangle, you can pass in all the parameters through, right? We just do one for this one here. So we're going to do like public triangle, and we're going to pass all those 4 parameters. Okay. So it'll be double. You can have the same name, it's fine. B1, double, B2, double, B3, and then double H. Okay. I have a mistake. Close that. Okay. And then we're just now going to say this set B1, right? If you remember that one, we set the B1, this set B2, okay, this set B3, so we set the data in this set H. Okay, so that constructor allows us to instantiate a triangle object, and it will pass all those 4 parameters at one time. Or you can create one object with no parameter, and then you can assign those fields separately using like t.getB or setB, so on. Okay. All right, and then now we're going to create a method to calculate the area of a triangle, right? So in here we're going to put public. So we're going to calculate the area, and then we're also returning the area back. So it's going to be returning a data type of double, right? And the name will be just say get area. Okay, and we don't need to pass any parameters because we can get those directly from up here. So the area of a triangle really is, the height times the base divided by 2, right? Or half times the base times the height, if you remember the formula for that triangle. And so we have to choose like which base is it. Of course, we could. So for this example, we'll just say the base 1, okay? Because it could be base 2, base 3, because the height would be different, right? If it's not what's called a triangle that has equal sides. Yeah, equilateral. Right. If it's equilateral triangle, then it doesn't matter which base is it. But if it's not, then we have to know which base is with which height it is. So let's just say that base 1 is always going to be that for the base, and the h is always for the base 1. Okay. So we return the area. We just say return the area is what? 0.5, right? 0.5 times the base 1 times the height, right? Actually, we should say this b1 times this h. I think that's the area, right? Base times height, and then divided by 2. Or half. So that is the area. And what about the parameter, or how would you do that? So double get parameter. That's easy, right? Just return b1 plus b2 plus b3. That's pretty much that's it. It's just the distance around that triangle or that shape. So that completes the triangle class. And we'll do the same for the rectangle. And the rectangle should be a little bit shorter. Okay, are we okay here? Do you need a little bit more time?
So why the area didn't go this B1, whereas on the parameter we didn't use the this?
Oh yeah. I mean, you can. Yeah, you can. Yeah, you. It's always safer to do that. In this case, I didn't do it because I have there's only one B1, right? If you have a B1 like in here, if you happen to have a B1 here, then now that's different, right? So in this case, if you still want to grab the B1 from the above, then you always want to put this here. So it grabs the data from up here and not the one it's local to this method. So yeah, right, you could do that. I mean, just to be safe, it's always safe to use this. It's kind of ugly here, but okay. As that, or you can even use like this get b1, this get b2. If the calculation is much more complicated, you call the method. But in this case, you just grab the data right away from these. I'm just going to put some spaces in here. Okay, So are we good? All right, so let's go to the rectangle class and do the same. So the rectangle, we need basically just two parameters, right? They'll both be double, and this will be just length and the width. Okay, so we need length and width, and that's all we need. And then again, just use the shortcut to generate the setters and getters or the properties. Right click, source, and then generate setters and getters, and select both of them and just click OK. Okay, so we're going to push these down so they're and then we'll create another method constructor here to accept those two parameters. So public rectangle double L and then double W, the length and the width. And there will be this set L, we pass in the L, this dot set W. And just so you know, you can see that how I did it so quickly without using any arrow keys, things like that. So when you do this in Eclipse, if I type in this dot and then set like W, I can highlight it and I tab it. Okay, I tabbed, well, I mean I selected, enter, tab it. It wants it here because it grabs the W, which is the correct one. So that's why it's always useful to use the same name. And in this case, I don't have to use my arrow key to go to the end of that line. I just press the tab key and it takes it to the end of that line. So it's much quicker that way. So I got that there, and then we're going to create those two functions to calculate the parameters and the area as well. So public double get area. We're going to return the area of this rectangle is just basically length times width, right? This L times this W. That is the area. Do the same for the parameter. Be double get parameter. So return this L plus this W. Actually times 2, right? This L times 2. Actually, you should do this way. Times 2 plus this W times 2. It's just basically the distance around the entire square. So it's like length plus width, and then I think you just times by 2 is fine too. So length times width times 2 is another way to do it. Okay, so those two are complete and they are ready to go. So again, you can do like page equal to length times width times 2. Okay, same thing. That probably should have been shorter. Okay, so now we're going to go into the main program. And so how do we create these two objects? We want to create a triangle object and a rectangle object, and then print out their, so set some values, and then print out their areas and parameter. Okay, so we have triangle, let's call it T, and then new triangle, right? Remember, we have two constructors. One is empty. If you do, I misspelled. If you do that, then there are no values. All the values are zeros, right? So we can do that, and then assign T set B1, T set B2, and so on. That's a bit long. So we're going to do all at once here. The base one will be just say 2, 3, 4, and the height would be just say 2. Okay, so remember it's base 1, base 2, base 3, and then the height. So for that t, right? And then we'll do another one for the rectangle. So rectangle, we'll call it R. So new rectangle, and this one takes 2 parameters. Okay. So if you don't remember what it looks like, you can always go back, or if you put your mouse in here, press the Control space bar to bring out this IntelliSense. It will tell you your constructors. So you have a rectangle with no data, and you have one here with the double I and L and W. So we're going to use this one, right? So we can have, let's just say it's a 2 by 2 rectangle, which is a square. Okay, so we can also easily calculate. And then now we are going to display the area and then the parameter as well, because all the data is already there, right? Okay, so just print out the triangle. So we're going to do a system out. So here's system.out.print line, and I'll say area of triangle is, then concatenate that with the t dot get area, right? So that's the area of the triangle. Okay, another way to quickly type out the system out print line, remember what I did last time was that you can create your own function to do that. Or if you type in SOUT and then press the Control space bar, okay, shortcut again. So SOUT, system out, or sys out, and then press Control space bar, and then it writes that up for you. Okay, saves you a lot of typing. And this would be like the area, well, the parameter of triangle is, and then we'll have the t.get parameter. Okay, I do the same for the rectangle. So SOUT area of rectangle is, and then r.get area, and then SOUT parameter of rectangle is r.get param. So I think that's it, right? So this is just like it's a review of what we had done before.
What was that shortcut? SOUT?
Yeah, SOUT, S out. Yeah. So for Eclipse, you have to S out and then press the Control space bar. If you were to use like IntelliJ, which is another really cool tool by JetBrains, if you type SOUT, and it automatically prints out that for you. So it's quicker. Okay, so I'm going to run my application here, see if it's correct. So click on the play, or press the Control F11, and then see if we have the data there. So the area of the triangle is 2, because we have the base, which is, we say B1, right, times the height, and then divided by 2 is 2, which is correct, right? Then the parameter is you just basically add all these 3 values. 2 plus 5 plus 3 plus 4 is, you get 9. Okay? And then the rectangle is pretty easy. Area is just 2 by 2 times 2. And then the parameter is you add them and then you times 2. So 2 plus 2 plus 2 plus 2. So I mean, nothing so different here. You have two separate classes, one for triangle, one for rectangle, and we instantiated two different objects of those two classes, and then we print them out, right? Okay, so now if you look at these two classes, the rectangle and the triangle, right? They have different parameters up here, different fields, right? But they have similar functions: the get area, get parameter, and the get area, get parameter. So if you look at this two classes, they are redundant, right? Either that or they are related somehow. And the only difference between these two, like the parameter and the other one, is just basically the formula to calculate those areas or those parameters. Okay, so if you think about abstract class, okay, you can make these two classes, triangle and rectangle, they are related somehow to a much broader class. We can call it what? Shape. Yeah, shape, right? The shape class. And then the shape class can have the get area and get parameter method. And then they'll be just like abstract methods. And you can implement those inside these two classes. And there's a reason why for abstract class. And I'll show you just a minute. So the book does it too. But if you look at the book, if you follow the book, he did show it as well. But if you don't read it carefully, you might not get what he's mentioned in there, because he didn't like. He could have, you know, make it bold or highlight it out so you can tell why is it important. Okay. So for now, are there any questions on how we create these classes? Pretty straightforward, right? Okay. So now we're gonna create an abstract class called shape. Okay. So now I'm going to go, and then we're going to go into why and when do we need these abstract classes. Okay, so we're going to have a shape class to make the abstract, and then we're going to modify these triangle and the rectangle classes, or maybe we don't have to, or just tiny, just a little bit, to inherit the shape class, and then we'll see how those work. Okay, so I'm going to do, so when we do that one, it's going to now go through these bullet points. So we will see that the abstract class will look just like a regular class. We have constructor. We'll show how that cannot be invoked by the abstract class, but only by the subclass, and so on. So let's do that. Okay, so going to create a new class. Okay, and this is going to be called just shape. And if you look at the modifiers here, so typically we just leave it at public, right? We leave it at public, but it has two, actually three boxes here to check. One is not shown here, but so we're going to check the abstract. We're going to make this class shape an abstract class, and if it has a superclass, we can put it here. If it's not, then it will automatically inherit the object class, which is the superclass of all classes in Java. Okay, we don't have any interface. We'll do an interface later, and so we can have a constructor is fine. Okay, so remember, abstract class can have constructors, but you just cannot create object out of it. So again, we'll leave the comments out. And then just click finish. So I'll move these up. So this is now an abstract class. So the shape class has, if you look at these two classes, the triangle and the rectangle, we did say that it has an area and the get parameter. They are related. Okay, so I'm going to put those in there. So in the shape class, I'm going to say down here, it's going to have a public method called so return type double get area, right? The same as we have it in here, the get area and get parameter. You can copy this and paste it here, it's fine. But now we're going to put the word abstract between the word public and double here. Okay, so abstract, go in here. Misspelled. Okay, so we have an abstract method called getArea, and again, you cannot implement this if you put the abstract. So in other words, I cannot go and do that. Okay, you cannot do that here. You have to let the subclass do it. Okay, it has to implement that. So if you have 100 of these, then the subclass has to implement all of them, whether or not they use them or don't use them. Okay, that is the rule. So so we cannot implement that here. We'll let the subclass do it. And we have another one, public abstract double get parameter. Okay, so we have two abstract methods in here. So with the abstract class, I can have, you know, constructor just like I would a normal class. You can have multiple constructors, like, because each one can take different parameters, okay, and so on. So let's just say if I leave it as this, okay, and then if I go into the main program, I mean, like up here, for example, you cannot do like shape s is equal to no shape. Okay, you see the error here. Okay, it would say cannot instantiate the type shape, doesn't tell you why, right? Because the rule is it's an abstract. It doesn't know what to do with it. So if you think, remember, a class is supposed to be a blueprint of an object, right? So if you think of the abstract class, it's a really broad class. It's a really broad blueprint of something, and it makes no sense. So you cannot build, well, it's like an incomplete you know, blueprint of a house. So you can't build it. So that is the rule, right? So that's why you say you cannot instantiate an object out of that class. Okay? It can only be done through a subclass. So now I'm going to convert both of these into subclasses of that shape class. So to do that, we just basically go into the class triangle, and at the end of that we put extends shape. Okay? And now shape is a child class. I mean, triangle is a child class of shape, and the shape is a broad abstract class. And then notice we also have the get area, get parameter. So in this case, we are overriding the parent method. Okay, so you could, here we could say override. You could put that that keyword there, so we know that we are overriding the parent's method, right? We could do that.
Do you necessarily have to?
No, you don't have to.
Okay.
Yeah, it's optional, but usually you put it there because if you don't do that, then sometimes it helps you to debug,
Right.
for debugging purposes. And also you look at it and say, oh, I know that this is a method inside the parent class, so it tells you what that is, but it's not required. Okay.
Gotcha.
Okay. So now watch. So if you look at my program here, if I save it, everything. Well, let's delete this line from the main method. So if I save everything, if you click that, or you click the save all here, and there should be no red axis anywhere, right? Because they're all good. Now, if I go back to the triangle class, and let's just say I either comment this one out, or yeah, like what if you like just say if we comment this out, if I highlight this, well, is there a shortcut? I don't remember the shortcut to highlight the comment. Yeah, so the control right, if you highlight it, the control backslash, I mean the / comments it out. So if I do that, if I save this, and then you save it, if you do that, you see that it has an X here for the triangle class. Okay, and if you go up to the class definition, it will tell you, if you mouse over this triangle, it will say the type triangle must implement the inherited abstract method called shape get area. Okay, because in the shape abstract class we have 2 of these, and so therefore any subclass that inherits extends that shape class must implement both of these. Okay, if you have 3 of them, you have to implement all 3. If you have 10 of them, you have to do all 10. Okay, if you have none, then there's none. So that's why you have to add it here. And if I do that and save it again, then the error goes away. Okay, so one of those subclasses must implement it. So if you have a third class that would inherit the triangle class, right? Then if that third class create or implement this get area, then it's fine. Then the triangle doesn't have to do it. So one of those child class subclasses must implement the get area class. It doesn't matter which one. Okay, as long as one of them does, then that should be fine. But in this case, we'll have one child class. Okay, does it make any sense? Are we okay? All right. So just to quickly show you that, I mean, like if we create another class, you don't have to do this. I'm just going to show you. Let's just say, I call it what type of triangle is it? Like a right triangle, right? Right triangle. Okay, this is inherits the triangle class. Okay, so if I do this, right, so it extends the triangle class, and that's another way how you can shortcut this. So it has 2 constructors in here, so it does all the constructor automatically for me. Now it inherits the triangle, so this triangle here inherits the shape, so you have the shape, the triangle, and then we have the right triangle. Okay, so if I take this out, or if I comment this out, or I just copy it, and then now I'm going to comment this. Okay, you see that we're back to the error before. It's again, you have to implement that shape. But since the right triangle is a subclass of the triangle, I could do it in here. If I put it inside the right triangle, there's some error here. So I mean, let's just say for now. I thought I did it in here already. Why didn't it didn't do it. So we have I'm not sure why it's not doing, but usually
because they're both, like if you put the parameter in the right triangle, the error go away.
oh, up here.
No, like the actual method. Like if you put the get parameter, like comment the get parameter out of the rectangle and put it into the for the triangle, I mean, put it into the right triangle, do they both have to be in there, or that shouldn't matter?
No, yeah, that shouldn't matter. Yeah. So this one is fine, as you can see. It actually goes all the way up to the parent class, but I'm not sure why this is not doing this. Okay, it could be something else, but usually the way it does is that since the right triangle is a subclass of the triangle, is a subclass of the shape, then one of these subclasses must implement that area. Oh, no. I mean, I'm sorry. Yeah, right. It can't be because you had to have, so if I do that, it has to be an abstract. Okay, and then it has to be an abstract. So you have to implement it inside a subclass, but if you don't implement it in here, then this class must be an abstract class. So again, back to the abstract class. Okay, so now if I do this, then yeah, this abstract class is a triangle class. I implemented the parameter here, but I didn't do that, and I let the child class of that do that area. So now everybody's happy again. So that's another way I can go down the tree that way. Okay, it gets complicated, but that's how it is. So let's go back to just those two classes. But anyway, so the rule is that one of the child classes must implement the abstract method. So I'm gonna put this back on. Okay, so now if I run this application, it should still be the same. It should just work just like before, right? No errors. Exactly the same. Okay, so I do the same thing with the rectangle. I can go to rectangle here and extends the shape class. Okay, so both the shape, the rectangle and the triangle are the subclass of the shape. The shape is an abstract class, and then the shape has these two common functions that are related to the two individual shapes. If you add a circle, same thing. Circle will also needs to implement the get area, get parameter, and so on for all the other shapes. So here is where the difference comes in when you do this type of application here. So now I have the triangle and then the rectangle classes. And so in the shape class, I can do this though. Remember, I couldn't do this. S is equal to new shape, right? I still can't do that because shape is abstract. Okay, so that's not good. But I can do triangle, okay, or rectangle. So the abstract class is above, and then below that is the triangle class and also the rectangle class. So the object is really a shape type. But then because this is a child of the shape type, I can instantiate the shape constructor using a child constructors concrete class to do that. Okay, so that's what it means by saying constructors are invoked by a subclass, not this abstract class. Okay, so what that means is, let's just say that inside the shape class, and this constructor, I put a message in here. I'll just say, you know, from shape class. So you know that it's going to be calling from that shape class. And if I run this file, when you get here, when you instantiate this new S, it's going to look inside. Remember the inheritance? It's always going to the superclass first, and it comes down that way. Okay, so again, in the triangle, instead of the blank, I just put another statements here. Say from triangle class. Okay, so you see the order of how these are called. Okay, so I want to run this application. So you see that when I instantiate, so this one here, the triangle T, when I do that, it's going to go into the triangle. It checks it if we have a parent class or not. If it does, it's going to go into the parent class. And then shape doesn't have any more parent classes. That is the parent class, so it prints it out. So it's calling the shape constructor, right? Not directly, so indirectly. It prints out this line from shape class. That's what you see from shape class, right? And then when I do the R, it's the same thing, right? So for the rectangle, I go into rectangle. It has a shape class. It's going to call the shape class, writes it out. So here it is again, shape class. Okay? And then the next line is the shape S. So shape S, oh, it goes into a triangle. So it calls a triangle. Triangle has a shape class, goes to the shape class, prints it out, shape class. Okay, that's what you have all three shape class statements there. But now we're not done, right? And then you have a from a triangle class. So that is, so after you call the triangle, you call the shape class first, and then it comes back down to the triangle, and then it prints out the triangle class. So it calls the child constructor, okay, in that order. So it calls that child constructor, and then now it goes out here. So the area, and then the rest are just like before. Okay, so you can see that it does call the abstract constructor, but you just call it from a child class. So not directly from the shape class, because you cannot create an object out of the shape. You can create it using a child method. So I can have a shape. It's a shape object, but it's created from the triangle. So that means this S here, right? It has the triangle, have access to these triangle information here, all these, plus its own data up here if we have other data up there. Okay, so that is the rule of the abstract class. Are there any questions on how the constructors are being called in this case, and how you cannot instantiate an object out of the abstract class? Okay. So before we move on to the next one, so the next two here, so say abstract classes and methods denote using abstract modifier. We did that already, right? The abstract method cannot be contained in the non-abstract class, and so on. So we'll do with those in a bit. So why don't we take a break, and we'll come back and we'll continue from here, and then we'll finish it off with the interfaces. Okay? So see you in about what, 10 minutes?